So today's lesson is going to feel and sound a lot like the last lesson we did on 5.1 and 5.2. But we're switching gears from, last lesson we talked a lot about bisectors of segments, midpoints, and that kind of thing. Now we're switching to angles. We're switching to angle bisectors. But they're going to have a lot of the same patterns and the same rules. We're just switching to angles today, and we're going to talk about medians and altitudes of triangles. So you may be feeling a little deja vu today as we go through this lesson, that it really is different than the last one. Remind you that next class, when you come in, we'll do a little bit of review, and then we'll have our quick quiz over this little short unit. You will be able to use your notes, so make sure you take good notes today. And wherever you see this little symbol on a page, make sure that page of notes you really got down well in your notebook. All right, so let's start with this idea of what is an angle bisector. Yesterday we talked about perpendicular bisectors, but today we're switching to angle bisectors. And as you know, an angle bisector is a ray. We talked about this a little bit yesterday. It's a ray, starts at this vertex and then heads out, right? And it divides an angle into two congruent and adjacent angles. Congruent and adjacent. So these two angles, this angle right here is congruent and adjacent. Remember, adjacent means they share a side. So it cuts it into two congruent adjacent angles. So the angle bisector theorem, and this is going to look like what we did yesterday. If a point is on the angle bisector of an angle, then it is equidistant from the two sides of the angle. So here I have my angle bisector, right? And I know that the point from any point on this bisector is going to be equidistant to the two sides of the triangle. So this distance is going to be the same as this distance. If I put another point somewhere on that angle bisector right here, I know it's going to be equal distance from here to here. Now, another neat thing that happens though is, so I didn't draw this one very well, goes this way. These lines that are drawn out to the sides of the angles, they will always form a right angle. The reason being is that the shortest distance, okay, if I'm measuring the distance between here and here, I could walk and walk and walk and walk and walk and then get there, but that would be a long way. That wouldn't be the true distance between that point and that point. The shortest distance between 2 points is a straight line, and that's the actual distance, right? And it has to be straight. So if I'm getting from AC, if I'm getting from this line right here, from this point to the red line, to the angle bisector, I have to go in a straight line. I have to go 90-degree angle out. That would be the shortest distance. Because if I go kind of to the side, that's going to be a longer distance. If I kind of go to the side here, that's going to be a longer distance. I need to go directly straight at it, which means this will always form a right angle when you go straight at that middle one, that middle bisector. So notice that it forms right angles, and that happens every time. Every time you'll form right angles, and each of these segments will be equal to one another. All right. So the converse of the angle bisector theorem says that if a point is in the interior of an angle, okay, well, what does that mean? The interior of an angle. So my angle right here is here and here, right? And this, since this is a ray, the angle bisector is a ray, it starts here and heads just one direction, right? So the point that I pick can't be out here somewhere, or out here somewhere, out here somewhere. It's got to be inside an interior angle of that green angle. So I have to pick a point inside. So if I pick a point that's inside the green, inside the angle, and it's equidistant from the two sides, then it lies on the angle bisector. So if I know that this line right here is congruent to this line right here, then I know that this point has to be on the angle bisector. And notice I came out 90 degrees from there and 90 degrees from there, because that was the shortest distance to get there. So, so that's the converse. So if I have a point out here, and it happens to be equidistant from that side and that side, if those two are equal, then I know that this point is on the angle bisector. All right, so if I'm going to find the value of x here, I'm assuming this is the angle bisector, then I know that this line and this line are equidistant, right? So 3x plus 5 is going to equal 4x minus 6. Subtract 4x from both sides. Subtract 5 from both sides. Looks like x will be 11 in that situation. Now this next one is talking about, notice the degree mark. So it's saying that this angle right here is 4x plus 10. Well, what do we know about these angles that are formed? There's going to be a right angle, right? So that means 4x plus 10 is going to be a right angle, which means it's going to be equal to 90 degrees. So 4x equal 80, so x is going to be 20. All right, again, we see that these angles are the same, so that makes this my angle bisector, which means that this line is equidistant from this line. It also means that I've got right angles out here. So to solve for x, I'm going to set 2x plus 5 equal to 7x. If I subtract 2x from both sides, 5 equal 5x, so x is going to be 1. On this one, let's think about this now. This is again talking about these degrees, this angle and this angle. Well, what do I know about the two angles? If I have an angle bisector, I know they're equal to one another, right? So I know that the angle 4x minus 1 is going to be equal to the angle 2x plus 5. Subtract 2x from both sides. Add 1 to both sides. Looks like x is going to be 3. Now, let's switch gears and talk about the median of a triangle. The median. Okay, think about the word median. Again, the median in a road. When you're driving down the highway, the median is that middle thing that's in the middle that keeps the northbound traffic from crossing into the southbound traffic, right? So median does mean middle. And so it is the middle of a triangle, but watch what happens. By definition, hint, hint, we've got that little symbol there. It's a segment from a vertex. So it starts at a vertex and then heads to the midpoint of the opposite side. So it has to go from a vertex to the midpoint, to the middle point of the other side. But it starts at a vertex. Okay, that's called a median. An altitude of a triangle. An altitude, remember, altitude has to be perpendicular. It has to be at a right angle. So an altitude of a triangle is the perpendicular segment, again, starting from a vertex, going to the opposite side or to the line that contains that opposite side. So to find an altitude of this, let's take this triangle QPR right here. I start at the altitude and I run down and I run 90 degrees. I make sure I hit that third side at a 90-degree angle. That makes it an altitude. Now, in this this situation, if I'm looking at this obtuse triangle, and I start at R, and I'm trying to hit the opposite side, there's no way I can hit it at a 90-degree angle unless I go this way, and then I hit it way out here. Now I hit it at a 90-degree angle. So sometimes the altitude is outside of your original drawing because it has to go until it hits a 90-degree angle. Okay. Now, on an isosceles triangle, okay, stop there. What is an isosceles triangle? It has two congruent sides, right? So in this situation, this side is equal to this side. And then the third side is its own little guy. He's not equal to them. So I've got an isosceles triangle. In an isosceles triangle, the perpendicular bisector, the angle bisector, and the median and the altitude from the vertex angle to the base are all the same segment. This is only on isosceles triangles. Okay, let's think about what that means. So I've got an isosceles triangle. The perpendicular bisector. Okay, the perpendicular bisector, this is from yesterday. The perpendicular perpendicular bisector, it was a segment ray or line or plane that is perpendicular to a segment at its midpoint. So here's the midpoint, and this line, sure enough, is perpendicular to this third side at a right angle. So it is a perpendicular bisector. It is also an angle bisector because it cuts this into two equal parts. So this line is also the angle bisector. It's also the median because it goes from a vertex down to the midpoint. I know this is a midpoint because I've got a mark here and a mark here. So since it goes from a vertex to the midpoint, it's the median. It's also the altitude because I start at a vertex and go at a 90, I hit this at a 90-degree angle right here. So that makes it an altitude. So on an isosceles triangle, all of those are the same thing. But that's not true on all triangles, and I'll show you in a minute why. Another thing to note is that in an equilateral triangle, okay, wait, equilateral triangle, okay, that's where all the sides are the same, right? In an equilateral triangle, then that last statement is true for any vertex. So if I go from, let's start with this vertex. If I go from this vertex down, then that is an angle bisector. It's also a perpendicular bisector. It's also an altitude. It's also a median of that triangle. If I go from a different vertex, let's say I go from this vertex, then I've got this line right here is an angle bisector. It's also a perpendicular bisector because these two are equal. It's also an altitude because of the 90-degree angle, and it's also the median because I started a vertex and hit at the midpoint. And then last but not least, I would do the same for the third angle, going from here, going out this direction, and that would be an angle bisector. It'd also be a perpendicular bisector because those two are the same, an altitude and a median. But that only happens in equilateral triangles. Okay, so an equilateral, it happens from any vertex. So let's look at this drawing here. I've got T, U, W. My question is UV. So I'm looking from here to here. I'm analyzing what is that right there. So my first question is it a perpendicular bisector? Well, it's perpendicular, okay, but the question is it a bisector? Do I know that this is equal to this? I don't. It's not marked that they're equal. It may kind of look that way, but we can't just go by looks. It has to be marked. If to be able to say this is a perpendicular bisector, I have to see that this length is the same as this length, and I don't see that. So no, I cannot say that it is a perpendicular bisector. Is it a median? A median, remember, starts at a vertex and hits at the midpoint. Well, do I know for sure that this is a midpoint? No, I don't. I don't know if it is or not, because again, I don't know that this length right here is equal to this length over here. So no, I can't guarantee that it's a median. Is it an altitude? Okay, that I can tell you it's an altitude, because if I start here and hit that third side, it doesn't say I have to hit at the midpoint. It just says I have to hit the third side at a 90-degree angle. But it does not have to be a midpoint. So yes, this is an altitude only. So you got to look real carefully at the definitions of each of these things before you can determine this. So keep your notes open, keep looking real carefully at all those different definitions. All right, we're looking at the red line again, asking these questions. Is it a perpendicular bisector? Okay, perpendicular means it has to be a 90-degree angle. It's not marked that this is 90 or this is 90. It doesn't even look like 90. So no, it is not a perpendicular bisector. Is it a median? Well, I don't know. A median starts at a vertex and hits a midpoint. Do I know that this is a midpoint? Absolutely I do, because this is marked equal to this. So yes, it is a median. Next question, is it an altitude? Well, an altitude has to have a 90-degree angle, right? And there is no 90-degree angle marked on either side of that line segment. So no, it is not an altitude. It is only a median. All right, let's look at this red one. This red line. Is it a perpendicular bisector? Does it hit at a 90-degree angle? Yes. And does it cut into equal parts? Yes, it does, because those are marked. So yes, it's a perpendicular bisector. Is it a median? Does it run from the vertex and hit a midpoint? Well, I could argue, yes, it does. I know this is a midpoint because these two are equal. So yes, it's a median. And is it an altitude? It's an altitude because it came from here at a 90-degree angle up. So yes, it's an altitude. So that'd be yes to all. So that was short and sweet. So here is your assignment from those two sections. And then the next class, we will do a review, the first half of the class together, and then we will take a short quiz. It will be open notes. So make sure you have your notes in class with you next time, and that they are well written out and you know what they mean. All right. See ya later.